Okay, so hello everybody. We are going to talk about Alloy, which is a MVC framework for Titanium. Did already some of you use Alloy? Yeah, so quite a lot. Okay, so let me introduce myself. My name is Xavier Lacot. I come from Paris, where I've created last year a company called JoliCode with some friends, developers also. We are specialized in developing web and mobile applications. While in the web side, particularly in the PHP technologies, we are really involved in the French PHP community. I've been last year the president of the French PHP Association. And on the mobile side, we mostly work with Titanium, well, almost only work with Titanium since some years already. And we have built several applications. And since some months, we are using Alloy. And we think it is a very good product that has to be presented in a conference like the TI conference. So during this talk, we are going to see, well, to remember fast how we develop with Titanium, usually. And this will show us that we miss a real rapid application development framework in Titanium. And then we will focus on Alloy and its possibilities and how you develop applications efficiently, fast, with Alloy. In the latest part of the presentation, we will see the title of the presentation, Better, Faster, Stronger. It's, maybe you know the Daft Punk title, the music title. I won't play music here, but we will see why Alloy is better, faster, and stronger than the usual Titanium development. So first, we are all here maybe using Titanium or planning to use it. So we are convinced that it is a good platform, but it's always good to remember why it is a good idea to use Titanium. First, it's based on very popular languages, which are easy to learn and widespread. Every web developer today has already used JavaScript, maybe only a little, only a few, maybe as an advanced level. But well, almost every web developer has already used JavaScript. We'll see later that it's not sufficient to be able to produce quality web applications, but it's a good idea to start using Titanium. It's based on open standards. It's not closed technology, it's open source technology. It allows to build cross-platform applications so that you can only code once using JavaScript and HTML and so on, and you can deploy several times. Well, it's not exactly the case, but it is a target. And finally, the third point, the third important point for your clients, it's that you can build real native applications. You are not building web apps or semi-native applications. It is real native applications, which are really fast, which can use offline capabilities, which can work when you're not connected to the network, and which have access to all the hardware features, the cameras, the GPS, and so on. So this is the arguments for Titanium, but there are some limits. Well, let me understand me well. I really like Titanium. I really love this platform, but for the developer, it's not a framework. It won't force him to work the right way. It's only a platform which gives him a lot of possibilities which can be misused sometimes. So instead of talking of Titanium like a framework, I prefer to explain people that it is a platform. It's not a framework. If you want to write a complete Titanium application without Alloy or without an MVC framework, you will have to use a ti.ue.create button function, create things function, and maybe you have used already Java Swing, which is crappy and something from the 20th century. But it really remembers me Java Swing when I create a UI using the ti.ui create xxx functions. So the platform is really good, but it is not really productive for creating graphical interfaces, and it is also unconstrained, so you can build the application the way you want. Sometimes it's not exactly the right way, sometimes it's not exactly the way your colleague would have done it, and it's not really constrained. That's the reason why there have been many MVC frameworks or pseudo MVC frameworks which have been created by Titanium contributors during the last years. And we'll see them. So the last point, because this framework is unconstrained, it can lead to a lot of problems. First, a sort of ti.include love by some developers who only do this. And well, in our job, we sometimes have to audit applications that other developers have made or that our clients have made themselves, and we have to help them to improve the quality. And sometimes we arrive on a project and we see a file with 200 include at the startup of the application, and of course it doesn't work. The startup of the bootstrap of the application is very slow, and we can understand it because Titanium has to load 200 files, and it's not efficient. These sort of problems that I won't tell much about all of them, but these sort of problems, it's only because the platform is not really constrained and it doesn't force the new developer to work the right way. It can work the bad way. As a PHP developer, trust me, I'm really conscious that it is normal. A lot of PHP developers develop like crap. Some of them try to do quality. So, I told you that there were several MVC frameworks which were created. I listed some of them. In fact, there are dozens of MVC frameworks for Titanium, but here are the ones that I thought were the most interesting and that had the most audience in the Titanium community. So the IQ framework, which is an open source project, of course, based on ENGS, Jews, and some custom classes. It has no community at all. No one is using it, and no one is contributing to it. Xtanium, which has even a website, which is sort of port adaptation of XJS in Titanium. It didn't change since June 2011, so almost 2 years ago. It has no community. TI-MVC, which also has its own website, which is based mainly on ti.include and which was not maintained and was not turned into a CommonJS compatible framework. And finally, Cranium.js, which was presented by its developer during CodeStrong 2001 and 2011, and which did not change since. So it has also no community. Seriously, there is a real problem. And therefore, Appcelerator thought to this problem. They saw that there was a real problem, that there was something to do, and the Alloy project was started. So Alloy, it is an open source MVC framework for developing rapidly fast quality applications using Titanium. It is based on the Titanium platform, and it complements these platforms. You are not forced to use Alloy to build Titanium applications, but you can do it, and it will improve the way you work with Titanium. It has appeared in spring 2012, so the first beta was published in June this year, and it uses a lot of open source libraries like Backbone or _JS, Uglify, and so on. It's built on Node.js and available through NPM. So for those of you who are used to develop server-side applications using Node.js, you will just find the same tools as usual. So if you build a streaming application which streams news and so on, you can use exactly the same tools for developing your mobile application now. It's rather well documented. I was used during the last couple of years to hear complaints about the Titanium documentation. Some people telling, okay, it's not telling the truth, it's written it should work, but it doesn't work, and so on. Well, actually, there is a lot of things on the Titanium wiki, on the Appcelerator wiki, about Alloy, and it is a project which manages to gather a small community. After only some months, 5 or 6 months of being a public product, Alloy has had almost 200 forks on GitHub. So it means that 200 people thought it was possible to improve the quality of the project and to contribute to it. So we finally have an MVC framework which is productive, efficient, well built on quality products, and which has a community and which will evolve. So what are the goals of Alloy? The first goal is productivity. If you have developed several applications with Titanium, except if you are the creator of the framework, maybe you know that your first application is normally a pain in the ass. You start really fast and then begin the problems because you didn't understand that you had to create nice interfaces and to use CommonJS and so on. So the first goal of Alloy is to avoid these problems and allow you to really go fast and develop fast. It is built on reusable libraries, so you can use the very same libraries on your mobile applications like on the server side. And also, the last point for productivity, it allows you to generate code. There is a Commandline utility that we will see later, which allows you to generate automatically code that you won't have to write yourself, and in which you won't make typos and mistakes. The second goal is to force you to use good practices. So say bye-bye to global variables and your 200 files inclusions during the bootstrap of the application. Now you will be forced to use good practices and to use an application architecture that someone else has thought for you. And finally, to improve the maintainability, today, as I told before, when there is a team of Titanium developers, one developer won't develop the same way like the second one, except if they have created their own MVC framework and so on. But the goal of Alloy is to standardizing the way mobile developers develop using Titanium. So if we manage to use all the same way to develop, we will be more productive, and beginning on an existing project or working on an existing project will be easier because there will be some conventions that everyone respects. So, what do we have to do to start playing with Alloy? The first thing is installing it. A few months ago, back in September, October, you had to install it by yourself, by hand. Now you just have to let Titanium Studio do it. If you install Titanium Studio, there is a small checkbox. If you check it, it will install Alloy, and end of the stuff. You will also have, before, install the Node.js and its NPM package manager, which will allow you to use all the libraries, all the open source libraries from the JavaScript sphere. What comes inside? First, Alloy comes with a Commandline tool, which is a very, very, very great tool to help you, because it will help you to create new projects. So you won't have to create project by hand. Well, you can also create the project in Titanium Studio, but it is a good idea to be able to do it from the command line. It will allow you to compile the project, so to check if there are compiled problems. It will allow you to launch the application if you are used to use an external code editor like Sublime Text or VI or I don't know what, and are not Titanium Studio, then it's really efficient and cool to be able to just type a command line and see the application appear. And you can also generate code. So we'll see later, you can generate controller codes, model codes, widget codes, migration codes, and so on. When we create a Titanium Alloy project, so what do we get? We get the very usual Titanium architecture, so with a build i18n, plugins, resources, manifest, app.xml, and so on. And we also get one more directory, which is the app directory. You were used to write your JavaScript code in the resources directory. You were used to put the images, sounds, style sheet files, and so on in the resources directory. Now, you don't have to do it anymore. It will be overwritten, this directory, every time the application is compiled. Now, all the code that you create, all the assets that you use, you have to put it in the app directory. It's a directory specific for Alloy. So, in this Alloy directory, in this Alloy app directory, we'll find several directories or subdirectories which have each their importance and their role. The first one is the assets directory, where you will put all the images, sounds, and so on of your project. It is the only place where you have to put them, and they will be compiled in the resources directory during the compile. The controllers go in the controllers directory, so it's very straightforward. The libraries, CommonJS libraries, either your own libraries or third-party libraries that you will want to put in a libvendor libraries, in a libvendor directory. You have to create this folder by hand. It won't be created automatically. And you will be able to load each library which is put inside this directory using the require command. Migrations. Migration, I don't know if it's clear for everyone what it is. When your application manages data, when it has a SQL database, for instance, embedded, sometimes you want to update the format of the SQL database. You want to add one column in the table, you want to create 2 or 3 new tables, and so on. You want to delete a column, change the name of a field. Migrations are specific classes which help you to make this operation on the phone of the user. Models are the classes which define your data model, which define which data you will work with. Styles, just like its name says, it's a directory made to hold the styles of your application. We'll see that it is very similar to CSS. For web developers, it's straightforward. The views are the viewable part of your application. It's the thing that the user will see. If you have seen yesterday's the visual UI presentation talk, then you have seen that it was possible to automatically create with drag and drop functionality views. So the views in Alloy are made in XML format. This is a big change compared to the traditional Titanium developments, because you don't need to use the ti.ui.create functions anymore. The widgets, there was a talk also yesterday specifically about Alloy widgets. Widgets are parts of application that are reusable and that you can distribute. And they are autonomous parts of applications with their own logic. For instance, a date picker, it can also be an OAuth login button, and so on. Alloy.gmk. GMK stands for JavaScript Makefile. It's a sort of Makefile which will hold several pre and post compilation operations. So if you want to log the compilation, to log a timestamp before this compilation, or to deploy the application to a specific server once it's compiled, and so on, you can do it in the alloy.gmk file. All this is explained on the Appcelerator wiki. You just have to read it. It's really easy. So the README, it's only literature, and the config.json allows you to configure several parameters for your application, for instance, URLs, and so on. And you can do it platform by platform. If you want to create a link in your application for checking the version of your application and telling the user, okay, there is a new version of the application, then you can just put the URL for Android and the URL for iOS on 2 different lines, and it will automatically be available in the application. So the only thing that you have to remember that now, never ever write code in resources. The directory still exists on the hard disk, but Titanium Studio even doesn't show you that it exists. You're really forced to use the app directory. How does it work under the hood? It's not a new version of Titanium, Alloy. Alloy is a component that comes on top of Titanium. You write code for Alloy, you write code using XML, JS, and so on, using a backbone, and so on. And at the compile time, it gets transformed into standard Titanium code. So Alloy, it is a sort of compiler which turns your code, your structured code Alloy, your structured Alloy code into traditional Titanium code, but which uses good practices, which won't be structured in a bad way, but which will be structured the way Alloy thinks it has to be. So Alloy does not replace Titanium, it goes on top of it. If we go deeper in the details, I've tried to represent all the things that you can find, all the concepts that you can find in Alloy. It's a very traditional drawing for MVC frameworks. But you will maybe understand better how it works. At the execution, we first start from the view, the main view, which is the XML file. And the view is animated by controllers. Controllers allow to add animation to the views. So we will see specifically each point after this. Controllers may use third-party libraries, and they may load data from the model. So controllers prepare data and put this data in the view so that the user can see it and use it. The view, well, we have said that it's only XML files. XML, it's not really nice to see. It misses some colors and some images. So it's possible to add style sheets to associate style sheets. It's possible to associate style sheets to the views so that it's nice to see for the user. And finally, the view can also require external widgets that maybe some other users of the Titanium community have created and contributed, so that you can embed this widget in your application. Or you can also create your own widget in your company for using it in your very several applications. Okay? So, let's start with the views. Views are XML files. I think that you have understood it now. There is at least one view in your Alloy application. It's the first view called index.xml. It's the first screen of the application. And one thing is important is you only have to understand that the XML files are not here to define the way your application looks. It only defines how your application is structured, how the views include themselves, and it's a sort of semantic description of your graphical interface. The style sheets are here to give some style to your views, exactly like a well-done HTML file would be styled using CSS files. here is an example of a main view. So the containing tag is alloy, and inside this tag we can create graphical interface elements. And if you want to understand what it should be in the normal traditional Titanium development, you just have to add a ti.ui.create string in front of the tag name, and it will give you the name of the function that will be called. So here we will create a window which will have a parameter class whose value is container, and inside that window we will add a label. So in only 3 lines we have written the equivalence of creating a new window, creating a new label, adding the label to the window, and displaying the window. It's rather efficient. Only one word about the namespaces. Some components of the Titanium API, like for instance the titanium.map.view graphical component, would be named view if I follow the namespace. So it's possible to explain in which namespace belongs the element that we want to add to the view. The default namespace is ti.ui, but we can also load graphical elements from the ti.map namespace or other namespaces if there are others. One thing we can see also is that this XML notation supports classes and IDs. So you can easily access to one element of the graphical interface, just like you would do it in HTML. I often do the comparison between Alloy and XML files and HTML, but just be sure that we are not creating web apps. We are talking of templating files, of XML templates, which are compiled after this. It's not interpreted on the phone. We can also add events, just like we will do it in a web page. So, the composition of the views. Here we have seen the first view of the application, but of course we want to divide our application into several very small files, and the smaller it is, the best it is, because we will be able to locate the problems when we want to improve our application. For this, we simply have to use the keyword require, which will help you to require some file. Here we will require a header.xml file, home.xml, and menu.xml. So our application will be constructed with a hierarchical point of view. This was for the architecture of the graphical interface. And then we can give it some colors and some look. The naming of the style sheets is very simple. It's the same name like the name of the view. So if you have an index.xml view, you just have to create an index.tss file in the style directory, and it will be automatically applied to the view. First, we can notice that we add IDs and classes, and we can point to these IDs using the very same notation like in CSS, using a well, I don't know in English how to say it. And the naming of the file is important. So you only have a few things to check in order to apply styles to your application. For controllers, so this was for style. For controllers, which are the business logic of your application, it's almost exactly the same way. You apply behaviors to your graphical components using a selector, using $.a points you, gives you, returns you the view with ID A. It's really easy. And the naming of the controller also has to be the same like the naming of the view. So if you have created a view index.xml, you can create a style sheet index.tss and the controller index.js. There are several ways to attach behaviors to your graphical components. Here we can see two ways. First, you can either attach a behavior from the view. So from the view, you will say, if I click on this label, I want to execute the doClick function. But you can also attach behaviors from the controller. Sometimes you will want to attach dynamically behaviors to your elements, and then you can just do it using the addEventListener function. It's really easy. That was for the controller part. It's really not complicated. Just one more word about controllers. We can define controllers for the whole page, for the index.xml template, but we can also do it for small parts of the page. Yes? Yeah, sure. Of course. Of course, these are only examples, but it's generalities. So, and we can also add the event listener on the T element, just changing the T here. So we have seen the views, the controllers. So we are missing the model part for MVC, for the MVC acronym. Your applications often manage data. For instance, the tiConf application loads data from the internet for telling you which are the timetables of the conference, which are the speaker, who are the speakers, and so on. So your applications really often manage data. Maybe you have seen yesterday the talk of GeoMafia about JSON-DB, which explain how to structurate your application and which libraries to use to manage data in your application. In Alloy, the data management is made through the concept of models. Models are indeed a concept inherited from Backbone, which is an open source library, MVC framework for the web, and it has a very strong data management layer. So how does it work? Your application, so the controller of the application, if we go back to this drawing, the controller of the application will want to use some data. So the controller of the application will call the model layer of the application, which extends backbone.model, the model part of the Backbone framework. And this Backbone model will use adapters to either search data in a local database or to load data from somewhere else. There are several types of adapters. So you don't have to when you are in the controller, you don't have to search if you have to use the SQL database or a local storage or a property storage and so on. It's configured in the model layer. From the controller side of point of view, you only have to say, I want this data. You don't have to know how it is stored. There are several adapters, so your application can either use SQLite database, the local storage, which will only work with mobile web, or the local default, which will default to the default storage of the platform, so SQLite for iOS and Android targets, and local storage for the mobile web. Or you can also use ti.api.properties, which will store your data as application properties. It's maybe not the best way to do if you have a lot of data, but it's a good idea also. Sorry? Okay. well, when I saw it, I really loved it. How do we create a data model? Creating a data model is done through the Commandline tool, which is a very good tool. And you only have to type, well, I will show you. I said I wouldn't do a demo, but I have to do it. So the Commandline tool, you just have to type alloy, and it gives you the list of commands available with the options. And if you want to generate a model, you just have to type alloy generate. So it will say me, no, I'm missing, what do you want to generate? I want to generate a model. And then model called tiConf, for instance. And then it will tell me, no, I'm missing the column names and the types. So it's exactly what I made here. If you want to generate a model called photo using the SQL Adapter, you just have to give all the options of the model you want to create, and you get a definition of the model in the photo.js file. A dedicated JavaScript file is created for defining your model, and you also get a migration class in your app migrations directory, so that the users who previously had installed the application can get upgraded when they install the new version. What do we find in the photo.js file? We find, like I said, the definition of your model. So first, there are 3 parts. The first part is the configuration of your model. Which adapter does it use? What are the columns? And what are the types of the different columns of your model? The second part is a section in which you can add your own business logic to the model instances. For instance, here I describe the creation of a photo model, of a model named photo. I could add a method for renaming a photo. I could create a method called rename, which would get a name as the first parameter. And then I will be able to call the rename method on every instance of a photo record. And the third part allows to extend a collection of photos, so to apply mass operations on the records loaded from Backbone, and you can do, for instance, filtering and so on, filtering operations, selections, and so on. It's something which is really common in the object relational mapping world. Just here, you don't have to care for the storage. And how do we use a data model? So we have created a data model, but now we want to use it. Once it is defined from the controllers, we want to load data. So we will simply use the Backbone notation, which you can find on the Backbone documentation. For instance, here we create a collection of photos. So we create a collection of photos. Photos here is the name of the model that we will use. Here we create a new photo. It's a new photo which we call, which name is on hotline, and it has a URL and it is enabled. So these 3 fields here are exactly the fields that we wrote here. And finally, we add it to the collection, and we can manipulate it just like we would do it in a Backbone traditional development. Yeah. Yes, you can go through the command line, or you can also directly create yourself the JS file. But it's most. There is no way to create a model. I don't think so. You can do right click. Okay. Well, I just found that it was more efficient using the command line. But once it's created, if you want to add fields, of course, you just have to open the file, add the lines, and it just will work. One thing is really interesting is that the models extend backbone model. So you have all the nice things, all the nifty things of backbone that you can use. If we have a model called photo, we can get an instance of this model and fetch all the pictures. If we want to filter, applying restriction on the photos, we can only load the photos for which the isEnabled parameter value is true, and so on. So it's really comfortable, and it's really a good idea to have used Backbone, because it is the most widespread data management layer in the JavaScript world at the moment. So yesterday there was a talk about widgets creation for Alloy. Widgets are really a very strong point for Alloy development, because it helps reusing components from one application to another. And you can see widgets like small autonomous applications inside the application. They are part of application with their very own business logic. A widget can bring a lot of things. It can bring views, it can bring only some methods, it can even bring data, it can bring assets, it can bring a lot of things. So every generic part of an application which is not very specific to your application should be developed as a widget. Just like you would develop using bundles in Symfony for people who are developing in PHP, you have to develop in widgets, create widgets. Maybe during the 1, 2, 3, 4 first projects, it will be a bit slow to have to create a widget directory and to create a widget instance and so on. You will feel that you are working twice at the beginning, but in the 5th, 6th, and the later projects, you will be happy to have a collection of components you can reuse, and it will really help you to go faster. Creating a widget is really simple. You can do it from the command line, and you will get a new directory created in the apps widgets and the name of the widget directory. So it's just like a whole application. It can contain views, controllers, models, libraries, so third-party libraries if your widget relies on third-party libraries, and also a widget.json file which describes the widget, who is its author, which are the requirements, the dependencies, and so on. To use a widget in a view, you will just require it like you would require another view of your application. So only use the require tag with the type widget, and it will be loaded from the widgets directory. Your widgets come with their own logic, but you can override the way widgets work. You can extend it and write your own method for the control. So, I'm almost finished. Widgets may pose a public API for the developer, for the application, for the widget user. So imagine I've created a widget which displays the date of today, or the date of today in a specific time zone. You, as a user of my widget, you will want to be able to tell the widget in which time zone you want to display the time. So it's a very important notion. You can pass data and information from the application to the widget. It is made really easily using the CommonJS export parameter. And of course, we can access the widget method directly from the application. So I don't know exactly what is the plan of Appcelerator concerning widgets. At the moment, there is no widget marketplace, but that would for sure be a very good idea to be able to package a widget in sort of zip file or I don't know what, and be able to to give it to the community so that other people can use it very fast. Maybe developing an application would turn into getting all the widgets that we could use in our application and assemble these widgets. One recurring concern about Alloy is, okay, it's very fast, it's very simple, nice, it's on top of Titanium, but look, I already have some problems compiling my applications in native Titanium, in basic Titanium. Now you add a new layer on it, so I will have more problems to compile. I will hide debug, and can I use the debugger to debug my XML views and so on? Alloy will help you indeed in developing, because it will show you directly during the pre-compilation, during the transformation from Alloy to traditional Titanium code. It will show you the mistakes in your JS code. So if you have forgotten semicolon, or you have made a typo and so on, you will be shown this. If there is an error in a XML file, you will get a specific error message, which will explain you what is the problem. So here I created an XML file with a problem, and I got an explanation which was really complete, and it was very clear to understand what was the problem. So Alloy does not add complexity to the debug process. So let's stick to the talk title. First, Alloy is better, faster, stronger. Why better? Because first, it is an MVC framework. For all those who are not convinced by MVC, I won't manage to convince you. But for all those who are used to develop websites and web applications and so on, and are already convinced by MVC, you just can be happy that it happens. It's built on top of high-quality JavaScript components who gather thousands of web developers in the world, and therefore it allows to broaden the community that Titanium touches. And the components that are used in Alloy are help you to create better application. It is better because now you have a dedicated syntax for creating views, XML syntax, for which we will be able to have productive tools like the visual UI tool that we have seen yesterday during the talk. We won't have any more to write by hand the code for creating the graphical interfaces, which was not the most productive way. It is possible to reuse and to write easier. If you start today developing with Titanium, I can only advise you to start directly with Alloy and don't try to write a simple Titanium application. Go on and directly create Alloy applications. And finally, maybe it can be discussed, but you don't have to know all the tips and tricks of the Titanium platform. I remember the old versions of Titanium, the first versions I used, when you simply had sometimes to copy one line and have it twice in your code, and oh, it was magical, it began to work. Now you don't have to do this. Just write your XML code for the graphical interface, and Alloy will turn it into the right way to do it using the Titanium APIs. So you don't have by yourself to discover all the tips and tricks that make something work while it doesn't work with one line difference. Alloy is faster. Developing with Alloy is faster. So it is the second word, the second keyword of the. It allows you to reuse widgets. So you will be able to use work that you have done before and that you don't have to do now. It's just faster. It allows you to focus on the functionalities of your app and not on the bugs that you will find every time that slow down your development. Using tools is possible. So if you have not seen it yesterday, I urge you to watch the video of the conference by Grant Smith yesterday. And it provides a standard way of developing applications. So if you're working in teams, you will be more efficient because your colleagues will be able to find really easily, okay, this screen, it's in this file, so the attached business logic is in this file, and the styles is in this file, and so on. They won't have to seek for the problems in your application. And it's stronger because it helps you to focus on the quality and not only on building and having something that works. You will rather search for quality and robustness instead of searching for only the functionality. Maybe using Alloy, you will start to get interest for unit testing, for automatically deployed scripts, for scripts for upgrading the vendor libraries of your application. And you will forget about only debugging your application. So, as a conclusion, Alloy is, from my point of view, a very, very great tool for developing strongly with Titanium, strongly, efficiently with Titanium. It brings a solid answer to those who do not know very well the Titanium development, but want to start to develop that first application. It's maybe not the same thing in all the countries, but in France, I've seen some French-written blog posts of people who are not very efficient and experienced in JavaScript, who only did some jQuery development before, and who are criticizing the Titanium platform because they are not conscious that there are limits in the memory, in the performance, and so on. As a platform, Titanium is maybe not sufficient for them for forcing them to write good code. Alloy will force them to write efficient code and to create efficient application. So the deception of the Titanium platform that they may feel when they are not forced to code in the right way, it will disappear using Alloy. So if you start using Titanium, start directly with Alloy. And finally, it uses a bunch of quality JavaScript libraries. So go on. Just one word more to say that Alloy is now a stable solution. It has been published in 1.0 version, so go use it now. Finished. Thank you.